Welcome to Study Loop.
Okay, so for the physical pendulum, the period equal to 2 pi square root moment of inertia over mass g distance from the center of the mass to the pivot. So from this equation, we can know that the moment of inertia can be calculated by period over 2 pi squared times mg d. Okay, period is 0.94 second. 2 pi, we know it. Mass is 1.8, g is 9.8, and the distance is 0.25 meters. Plugging the number, we can get that the moment of inertia is 0.0987 kilogram meter per meter square. That's for question A. For question B, so in the beginning, suppose this is its center of the mass. This is center of the mass, and in the beginning you have the angle theta, which is 0.4 radius. So the beginning, this height is, so this is your d. This is d cosine theta. And when it passes equilibrium point, this is d, the height is d. So you have the height difference between here and here going to be d1 minus cosine theta. So the change of potential energy is mg, the change of the height, which going to be equal to the kinetic energy it gains, right? All the potential energy from here becomes kinetic energy at this point. So we can know that the velocity is equal to 2g d1 minus cosine theta squared. And the angular velocity is equal to velocity divided by radius, which is d in this situation, right? So we plug in the number and have the maximum angular velocity going to be equal to 2.66 radius per second.